Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all of you. So I'm making this video just to explain a little bit about the solution of example 3, I think, from our previous class regarding the questions, which is find VO. Okay, so to make it short, okay, so we assume that we have already calculated the mesh current, which is I1, I2, and I3. Okay, and from that, you are required to obtain the VO. Okay, so it might be confusing because the polarity of this voltage is not given. So it can assume the polarity to be either positive, negative, or negative, positive. Okay, so but regardless of the position of the polarity, you will actually will end up with a same answer, which is 30 volt. Okay, so let's begins the solution for this example to get the VR. Okay, so I can redraw my circuit. So actually V out is actually consisting of 2 volt voltage drop, okay, across 2 resistors. So assuming that the polarity is like this, okay, so by using the KVL, you will receive that your V out is equals to positive V1 plus positive V2. Okay, and right now, what is your V1? So V1, okay, based on this circuit, we assume that the net current, okay, so because right now we have two mesh current, I1 and I2, which are in opposite direction. Okay, so we assume that I1 is bigger than I2, meaning that the current will flow from positive terminal. Okay, so that's why you have positive. So the net current is I1 minus I2 and multiply with its own resistor. So this one, I1 is 3 and I2 is 2. So you will receive the answer is equal to positive 1 multiplied with 10. So 10 volts. Okay. And for V2, so we have only a single current, which is I3. Okay. And based on this one, we see that the current I3 will entering the negative terminal of the resistor. So meaning that you need to have this one negative I3 multiply with its own value resistor. So negative, and then you substitute the values of I3. So it will be negative 2 multiply with 10 ohm. So you will receive 20 volts. So VO is 10 volt plus 20 volt, which is 30 volt. Okay. Okay, I think you understand this one. What if the polarity is changed? For example, V1, I assume that polarity is like this, and for V2, the polarity is like this. So based on the KVL, I can write down my KVL. So my V out is equals to negative V1 plus V2. Okay. So right now, what is my V1? So my V1 is right now we have two current, right? Two current, I1 and also I2, but we assume that the current is I1 is bigger than I2, so we can write down is this one is equals to 3 minus 2 multiply with 10. Okay. And as you can see, it's actually entering the negative terminal. So this one should be negative. Okay. So your V1 is negative 10 volt. Okay. And then your V2. So your V2 is the current is entering the negative terminal. So negative I3R. So this one negative 2 multiply with 10. So you obtain positive 20. So right now you have V1 is negative 10 and V2 is positive 20. So if I put again, so this one negative 10 plus 20. So I will receive the same answer, which is 30 volt. Okay, so let's now try to have a polarity change. For example, I change the V2 polarity into this one. So what happened? So same, you need to do the KVL. So V out will equals to negative V1, negative V2. And so for V1, the current is entering the negative terminals. Okay, and then the net current is I1 minus I2 multiply with the resistor. So negative I1 is 3, I2 is 2. So this one is neg 1 multiply with the resistor. So you should get negative 10 volt. Okay. And what about V2? So V2 right now, I3 is, okay, is entering the positive terminal here. So meaning that you will obtain positive I3 multiply with the resistor. So positive I3. I3, you substitute the value, so it will be negative 20 volt. Okay. Then you substitute this value, so negative 10, negative 20, you will obtain 30 volt. Okay. So I think I clarify the some of the unclear explanation on the polarity of inside the circuit of the example 3. Okay, thank you very much.